All right, this is Mr. Gillum, and today we're going to talk about angle relationships, and we're going to use some proofs on our angle relationships. So all that complement and supplement stuff that we've been learning about, now we're going to have proofs about it too. And we're going to start with this angle addition postulate. Okay, and what the angle addition postulate says, I'm not sure if I have a good example in these notes or not, but so keep this one in mind. The angle addition postulate says basically if you have this point right here, D, and you know that ABD plus CBD is equal to ABC, then you know that D must be somewhere in between ABC. It's on the interior. All right, it's on the interior. So whenever you're adding those angles together and they're not supplements or complements, it's called the angle addition postulate. Okay, so if it's not a linear pair, or it's not a complement, then that's what you're using. Okay, I want this little thingy. No peeking, no peeking, no peeking. Don't want you to surprise. Okay, it says the following things. Find measure angle 1 if measure angle 2 is 56. I'm going to draw that in there. And angle JKL is, we're going to say it's 145. I think I missed, yeah, it's supposed to be 145. I have a typo there. That wouldn't make any sense if it was 45. So we're going to say this guy right here is 145. All right, and what we need to find is measure of angle 1. And we'll justify each step. When you see these words, you learn to love them. That means you need to use a proof to show your work. So we're going to start with the given, and I forgot that we've been writing the given on the right-hand side. So with the given, they tell us that measure of angle 2 is 56. They also tell us the measure of angle JKL is 145. And what we don't know is measuring 1, but all that information, that's the given information. Okay, it's given information. Okay. Now, we know that the measure of angle 2 using the angle addition postulate, the measure of angle 1 plus the measure of angle 2 should be 145 because of the angle addition postulate. So angle 1 plus angle 2 should equal the whole angle. Angle addition postulate. I'm going to use substitution on the parts that I know. So I know that measure angle 2 is 56, so I'm going to substitute that in there. And I know that JKL is 145, so I'm going to substitute that in right there. And so now I have substitution. I have measure of angle 1 plus 56 must be equal to 145. Okay. That should be the substitution property. Not that. I don't know where that came from. The substitution property. I don't know why it says that. Okay, measure angle. Okay, so now we just have this nice equation. We're trying to solve for measure angle 1, so we're going to go through our steps. We're going to subtract 56 from both sides using subtraction property of equality. And instead of skipping straight to the n, I'm not sure why it says that either, we're going to use all those other little properties that we have on that we've been working on. The measure of angle 1 plus 0 equals, let's see here, 89. And what we did there was additive inverse. And we simplified the right-hand side. And so when we add nothing to something that stays the same, it is the identity property of addition. So there you have it. You have a nice little proof there. We use the angle addition postulate. I don't believe I left you enough spaces on your chart in your notes, so might have to add a space or two for these two properties at the end. So there you go, angle addition postulate. The supplement theorem is something we've been talking about already. Basically what it says is if two angles are a linear pair, then they are supplementary. We know these things. Angle 1 plus angle 2, since they make a straight line, they make 180 degrees. Complement theorem. If the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. That sounds really confusing. Basically, complementary angles will add up to 90 degrees. Okay, they add up to 90 degrees. All right. Using a transit, a surveyor sights the top of a hill and records an angle measure of about 73 degrees. What is the measure of the angle at the top of the hill with the horizon? Justify each step. Okay, when you see that justify each step, once again, I want to make sure that you know that means you need to make a proof. So the way this works with these what's it called? The transit is, it's telling me that this angle right here is 73 degrees. Angle 1 is 73 degrees. Okay. And so I'm going to actually call that part of my given. You know, I forgot about that. I don't want you just peeking at all the answers here. I think I might change some of them again. Let's see here. Where's my, there we go. Oh, there we go. So I want to make sure I have my given information for sure. Darn it, I did it backwards again. My given information. Measure angle 1 is equal to 73. And I know that, what else do I know? That might be all that I know, actually. And that's the given. All right. And so now I know that through the complement theorem, I know that measure angle 1 and measure angle 2 must be equal to 90 degrees when you add them together because they're complementary angles. So the complement theorem. See what this next step says. Now this guy right here, we're going to say substitution property. All right, the substitution property. We're plugging in the 73 degrees from our given into measure angle 1 because we know that's how much it is equal to. And then we're just going to solve our equation. So we're going to go with the subtraction property of equality because we want to know what measure angle 2 is. And we'll move on here. I think they're going to leave out a couple steps again. Yes, those stinkers. All right, guys, go straight to there. We're going to subtraction property. We're going to combine like terms or simplify. On this guy right here, when we're adding opposites, we're going to call that the additive inverse property. Additive inverse. And we're also simplifying the right-hand side. And then when we add 0 to something and it keeps its identity, so we're going to say the measure of angle 2 must equal 17, the identity property of addition. Identity property of addition. Okay. So proof's really similar to what we did the other day. We're just adding complements and supplements basically into the mix. And oh yes, I forgot about this one. There's a booger. Okay, yeah, he's a big one. Okay, so I'm just going to leave it up there for you. And you know what? No, I'm not, because I think you will not listen very well if I leave it up there for you. So I'm going to clear it out. It says angle 6 and angle 7 form a linear pair. So that tells you that they should be adding up to 180 degrees if we know anything about linear pairs. It also tells us the measure of angle 6 and the measure of angle 7. We need to find three things: x, measure angle 6, and measure angle 7. We do those things. Justify each step. So that little guy right there tells you we're making a proof. Oh, before we do that, we're going to say the given. The given information. Oop, the given should go over here. All right, we're going to put the given information. All the things you need for your given information include they form a linear pair, what measure angle 6 is, and what measure angle 7 is. That all needs to be part of your given. So I'm not going to rewrite those right next to it. I'm just going to tell you, you need to write them down. Okay, so the next thing I'm going to think is, okay, well, I have this given information, and since I know that they're a linear pair, that tells me, the supplement theorem tells me that they must add up to 180 degrees. So angle 6 plus angle 7 has to equal 180 degrees. Now ideally we'll find x first. That's what we're trying to get at. We need to know what x is so we can find measure angle 6 and angle 7. So what I'm going to do is I'm going to substitute in what they're equal to from the given information. I'm going to substitute in 3x plus 32. I'm going to substitute in 5x plus 12. Equals 180. Now I have this nice looking equation. I can start solving to get what my x value is, which is the first thing that I'm looking for in my proof. As I combine my like terms, I can go ahead and start solving for x. So subtract 44 from both sides, the subtraction property of equality. And then as I subtract, I add opposites. That's the additive inverse. And over here I am simplifying. When I add 0 to something, it keeps its identity. And now I'm using my division property to get the x all by itself. But I know that 1x, if it equals 17, then I know that x must equal 17 through the multiplicative inverse property. I'm simplifying the right-hand side. I'm just simplifying that. The identity property says that a multiplication says if I multiply by something by 1, it stays the same. And then I'm going to stop right there. I figured out what x is, but we have to answer all of the parts here. So I have the first part answered, x equals 17. I'm going to go ahead and try to find what angle 6 is. So what I'm going to use is, I'm going to use angle 6 equals 3x plus 32. This is given information. And I'm going to use substitution to plug in my 17. That's what I know x equals. Now I'm going to do some simplifying, so I know angle 6 must equal 83 degrees. Similarly, I need to find angle 7. So I found two of the three things I need to find. Angle 7 from the given information tells me it's equal to 5x plus 12. So through substitution, I can plug in that 17. And finally, when I simplify, I know that angle 7 must equal 97 degrees. So I know now that I know I've proved every single part, then I know what x is, I know what angle 6 is, and I know what measure angle 7 is. And I've justified each and every single solitary step. And that's it for today. So we got some more proofs to do. We're not throwing too much on you, but a little different than before.